The other thing that would kind of bugged me about the last test is that there are two things I want to say about it. One, I gave you guys the opportunity. I told you the two first questions on the test and said, if you figure them out in advance, I will tell you whether you're right or wrong. Okay. I think like 3 or 4 people did that. That was disappointing. I spent the time and made notes of all the proofs that I gave you. And I think like 3 or 4 people watched them. Okay. I'll tell you what, when I sat down to do those, I said to myself, this is going to take me about 20 minutes to do. If nobody watches this, why am I doing it? Right. So these are things that are kind of given that you should be doing as part of this class. Okay. All right. Anyways, 5.1. So there is a theorem that's called the perpendicular bisector theorem that says that if you have a perpendicular bisector, then automatically these sides are going to be congruent. So go ahead and let's mark that on there. That's what the theorem says. That if you have a perpendicular bisector that's cutting that triangle in half, then those two sides are congruent. And actually what it says is that any point that I would put on this perpendicular bisector, so if I put a point way up there, then if I drew from here to here, then these two would also be congruent. And I could keep doing this. Any point that I put on there would be equal distance from X and Y. Okay. And then the backwards, so the converse of that, just says, so if I can say that these sides, or if it's a perpendicular bisector, then these sides are congruent, then I can say if these sides are congruent, then this is a perpendicular bisector. The only thing that really bugs me about this converse and the way that they did this is that you would have to say that this is a 90 degree, okay? Because I could draw a triangle that was that had these sides congruent, and what they're saying is if I then draw straight down, this is the perpendicular bisector, okay? But I could draw like this. Is that a perpendicular bisector?
No.
No. So it's got to like be straight down. Yeah.
So if we have the perpendicular bisector, how do we automatically know that those lines are congruent? Because they could be different sizes.
They're saying it's impossible. So if I put a point anywhere on this perpendicular bisector, then it's impossible for me to not make them congruent. So I picked this point here. Oh, I picked that point, and then that means that has to be the same as that. Okay. So then the proof of the perpendicular bisector, and I don't know if I needed it, but I gave a space down here to write the proof. This is probably the type of question that shows up on proof worksheet number 1 is to do something like this. Basically, I have to prove that this side is congruent to this side. That's my job. If I can prove that this triangle here is congruent to that triangle, then by corresponding parts of congruent triangles, then I can say that they're congruent, those sides. So, okay, I'm listening.
You do X to Q is congruent to Q to Y, because that's given.
Okay. That's one of our sides. So some of you like to write the side out here. That's given. Okay, I'm listening.
Angle PQX is congruent to angle PQY.
That's
supplementary.
That's supplementary. I would also accept given on that one.
Yeah.
Because they gave you the 90 degree. I mean, that's kind of a weird one because they gave you the 90. So supplementary 90 degree angles. How about
for the final side, we do PQ is congruent to PQ.
Okay, PQ is congruent to PQ. That's reflexive.
And then triangle, no, segment. Oh, we gotta say the triangle PQX and triangle PQY are congruent. Y side, angle side.
And then X and B,
So we always want to write it the exact.
side DX is correct. Side physics.
So they did not put, what did they write? They didn't say side. They said what? Do you remember what this means?
Line, yeah.
Not line.
No.
When they don't put the bar on top, does anyone remember? There's no bar, so that means segment. So this means segment. It's the distance. Okay, so when they don't put that bar on there, they say distance. And when you say distance, that's why it's an equal sign and not congruent. If you put a bar on top of that and made it congruent, I wouldn't take any points off. But that's what I'm showing you there. So that's just different. Okay. So I think partial of my fault with the proofs is when I started throwing proofs at you, we jumped in the 15 feet water rather than tiptoeing in. I take some responsibility for that.
Yeah, just like,
Okay, so this is the math that they want us to be able to do. So again, if we have a 90-degree angle here, and these sides are congruent, then that means that this side here and this side here are congruent, or
That you have 5 and minus 2.
so all we need to know then is that this is congruent to this.
It is.
So if those are congruent,
You have 5
And
and
equals
minus
3.
2.
so I just said they're equal to each other. N equals 3.
Yeah.
Now I want to point out something, and the computer probably doesn't let us make these mistakes, but have I answered the question? No, the question asks what?
What is the value of 5? So you have to input 3 into the equation.
12.
13.
It's
6.
13.
Yeah.
I added the 2 and 3. Chill. I forgot algebra for a second.
Trust me, I've done that.
Don't have to kill me.
This one's kind of interesting because you actually there's no calculations I think you have to do. There's one simple one, but you have to know the rules. Okay.
You just use Pythagorean theorem.
It's simpler than that.
I remember the Pythagorean
All right. So the directions say essentially what the perpendicular bisector says is that if these sides are the same and you have a 90-degree thing cutting it, then these sides are the same.
Yeah.
Okay.
So that means N to L is
Oh.
N to L is 14.
That means that because these are the same and this is 90 degrees, then these are the same. This whole length here. So he just told me that from N to L is 14. That's not what we're looking for, but that's helpful because then this is the same as this, which means that this cuts it in half.
Would that be given?
We're not proving it. We just have to give an answer. So what is the answer?
Oh, well, you just said it.
Okay. So if this was 18 right here instead of 17, then we'd say we can't do it. Okay. But
Unless both sides were 18.
so it reminds me of isosceles triangle proof where we said, or isosceles triangle theorem, where it said that if the two sides were the same, then the angles are the same, the base angles. But instead, we're saying the two sides and this is 90 degrees, then that's cutting that thing right in half. It's impossible to make this 90 degrees without cutting it in half. Okay. This would be something that you would use a ton in building, right? If you knew that this piece of wood was 17 and this piece of wood was 17, then to make this a 90-degree angle, you would just make these two the same here. And it would force a 90-degree angle, okay? So a lot of times when people are trying to figure out, did they make a 90-degree angle, they almost never measure to see if it's 90 degrees. They use tricks like this to say, if this is the same as that, then it's got to be 90 degrees, okay? There's another set of theorems that we need to learn is the angle bisector. So if I have an angle and I cut it in half, and this line here, if I pick any dot on this line, so they pick this one, and go 90 degrees off of the angle, what do you think is true about these two lengths? They're the same. Those are congruent. So if I picked another dot here, and if I extended this out, and I went like that, and I went like that, then those lengths would be the same. So I could keep doing this and pick any dots I wanted.
Why would this be useful in construction?
I think this would be useful. A lot of times they would use more like the converse, okay? Where they would say, if I know if this length here is the same as this length, then I know that these are 90-degree angles, okay? I almost could see, and I'm making this up a little bit, but when people make baseball diamonds, okay, there's a lot of math that they use, and they probably don't sit there and calculate it, but they know tricks like this, the length from second base, okay, needs to be the same distance from first to second, and that's how you kind of know that you're doing right angles, okay?
Is that a baseball diamond like all right angles? Or second to third and third to, no, first to second, third to second to third. Are those right angles?
I don't think so. I think
First to home and third to home.
I think so, but I don't know. But you would use all kinds of tricks to doing that, okay? You wouldn't find the guy probably sitting out on the field calculating things, but he would kind of know. He or she.
Joining freaking integers and combining like terms.
No, I hated that. That sucked.
I like that.
That was fun.
And I like kindergarten where I was ahead of everybody.
Wait, you learned that in fifth grade?
I learned that. I missed normal math.
I didn't remember.
Don't we all?
I thought we learned
And
that
then
in
logic.
algebra.
Okay.
All right, so basically what we need to know when we see these are 90 degrees, okay, and then we basically need to know that this is going to end up being the same as this, okay, and that this is the same as that. So if HI is 7, okay, they told us that. If HI is 7 and IJ is 7, then that information tells me because these are the same, then that means these angles have to be the same, okay? If this was an 8, then those angles wouldn't be the same. And this is how you might construct something on like a baseball field where you know that if this was 6 and this is 7, you might go, it's not quite right.
What I got wrong on the test, one of the questions were like something about those, and then there were like multiple choice, but you had to pick more than one.
Yes. I think every single person got those wrong.
Yeah.
Yeah, maybe we need to discuss those. Okay. So then they tell me that HGI is 25. So they want to know what IGJ would be.
It's 25.
It would be the same. Yes.
Is there a way, like, for the test, like, to show us what we got wrong, so I know, like, what was right, so I know how to fix it next time?
Do they show you after you take it?
No,
It's
it
like-
shows you that you got that.
Okay.
But it doesn't tell you how you got it.
Okay.
Yeah, that's
Well, what the
Because
right
when-
answer is,
sometimes, like, I'm
you go
debating
right
between
answer,
two,
then
and I
you
want to see this one.
And then, I want to see, I don't know the answers.
That's how I do it.
So unfortunately, to answer your question, when I look at your test results, like if I want to figure out which questions you missed, and I want to figure out which questions you missed and you missed and you missed, I have to like click on your name, click on your test, look at each individual question. It's not easy to do. So what we can do is on the next test, you can write down the questions that you missed that you feel like I have no clue why I missed them. Okay, and there might be even some that might help me with rounding. Okay, so if every single person missed the same question, then maybe it wasn't a fair question.
Yeah.
Okay.
That's exactly.
So.
Oh, yeah, that's what happened in Mr. Gali's. We were taking a test, and one of the questions
Literally
didn't have an answer.
and I figured that out. And I was like, this
Yeah,
is
because Mark said it 3 times.
All right, so the next question unfortunately uses the same shape. So I have to kind of cross out these numbers. So it says HGJ is 57 degrees, HGJ. So that's the big angle is 57. And then they tell me that IGJ is 28.5. That's this angle here. They tell me that HI is 12.2. What is this? So they're getting at if this angle right here is not the same, then I can't say anything about this. What is half of 57? Because it's 28.5, because these RN end up being the same, then I'm allowed to say that these are the same. So when it asks me for IJ, I can simply say that it is 12.2. Okay. So hopefully there are triggers that show up that if these angles are the same, then they're going to be talking about these sides. Okay. If I look at the other side, if these angles, if this is a cut 90 degrees and it's a perpendicular bisector, then it's going to say something about these sides. Or conversely, if the sides are the same and it's 90 degrees, then these are the same. You had your hand up?
Yeah, I was gonna say, if we are like halfway through an already lesson, does that count as one lesson? I'm gonna go.
When you pass it, it counts. So if you've started one, finishing that one will count.
Mr. McConnell. So does the grade you put, your test grade that you get at the end, for completing it, you get 100.
Exactly.
What on what?
The I read it.
Complete. If you get a passing grade, which I think is 75%, you get 100 points.
Oh, I get
It's not 75% because I got an 80 on one of them. I
It
read
tells you at the
lesson
end.
quizzes and then we put it back in.
Because you
I
put
got an
that.
80%.
I've had to redo so many.
Well, I think there are multiple scientific notation ones that look similar. No? Okay.
They're always the same. I've retaken it 4 times already.
Well, Ben, that means you're failing the test.
No, I got it all perfect.
I know, that's me too. It just makes me redo it.
Okay. Well, we can investigate that.
I'm on the
Subar, if you wanna look at that, I'm not here, so I can't really help you, but you wanna investigate that.
Just ask me, I'm on lesson 7.
You're on lesson
Can
one.
we
No, it's
go,
not.
can we go to the computer lab with this stuff?
I don't think I want you to.
You know who the sub is?
Because of bio.
It's Mrs. Loftman, the math coach. All right, so I just realized that this makes a lot of sense to go ahead and just write on this proof. Oh my gosh. Worksheet number 1 is these 2 problems, okay? Number 1 and number 2. So there's clearly not enough room on this to do those 2 problems.
So this counts as worksheet 1 and 2?
No, this is worksheet 1, has 2 problems on it. So make sure you do it on another sheet of paper. I do not want to give you time right now on this because I want to do the 2 proofs from the test. Do you guys want to see those proofs? Okay.
Especially the parallelogram. I was so
Mr.
confused.
McConnell,
Yeah.
so if we fail on the first one, we have to do the second one.
On these, you have to do both of these.
Oh, no.
If you have both of them correct, then you get credit for that 100%.
What if you get both? One right.
Then I might make you do one more.
And then
Okay.
what if we get that one?
Then I might make you do one more.
And then that one.
Basically, you're going to do it until I'm satisfied or you get a 0.
Okay.
Okay? You want to go ahead and get out a piece of scrap paper? Do I need to give it to you? Do you want to
Scrap paper?
scrap?
Why?
Yes.
Why?
Because I'm going to do these, and I assume you want to write them down.
Well, not really.
You just want to watch?
Yeah.
Yeah,
Okay.
I wanna witness magic.
It's a lot easier when we don't have to stop.
Yeah.
Okay. I don't mind.
Can we wait?
It'll be easier if you don't have to stop.
Can we turn the light off? I can't see anything.
Can we turn the front light off?
I like that and figure that how many times.
Usually that doesn't make it any better.
Actually, so I can actually see it.
All right, so we need to prove that triangle ACE is isosceles. And I was kind of surprised by some of you because I remember one question somebody said, I don't know what it's called when the two sides of the triangle are the same.
Congruent, question mark?
And they said, I'll just leave it blank. And I said, you should put something. And they said, I don't know, maybe it's something like definition of isosceles. And I was like, oh, that surprised me because it was absolutely right. So I don't know if it's confidence, like we're just unsure of ourselves with these for now. Okay. Also surprised that some people like just put down one or two things that were right and then stopped. Okay. So if I can show that this side is congruent to this side, then I have proved, or I have everything I need to prove that triangle ACE is isosceles, because that's the definition of isosceles. So I'm going to prove that this triangle is congruent to this one, okay? And I always forget the rule that says if this big triangle, if these two sides are the same, then I can say that these angles are the same. Now I got to be careful because I mark that, and I know that students, once they mark it, they want to say given, okay? But if it's in red, it's not given.
If we put that there, but we use the completely wrong proof, like the wrong given, do we still get any points for that, or?
Usually what I do is I'll give you a point. You'll lose some points, but I'm looking more for logic overall, okay? So you'll get credit for telling me that this is congruent. These sides are congruent, the given parts. You'll get credit. And most of us did that and got some credit. But if the rest of it's just a mess and doesn't end up telling me anything about the isosceles triangle, then you're not going to get much credit. If you made a simple mistake, every logic is good, but you put the wrong reason, then you lose just a little bit.
Can I start?
Sure.
Right, the B and A is equal to A and F.
Okay. So one other thing I want to say is I think another thing that we're prone to do is say things that we're not allowed to say. Okay. We go, I know it looks like it's congruent, but you're not allowed to just say that because it looks like it. Okay. Well, I'm sorry. Say it again, Mark.
So A and B.
Segment AB.
Yep, is equal to AF.
AF. Okay. So there I would have given you some points.
BC is congruent to EF.
I would call it AFE, but I wouldn't take off if you said it the other way. Okay. Ben, did you have your hand up for? Okay.
And then
You say,
you say that angle AFE
Can I just call it F?
is
Okay, so isosceles
Yep.
base theorem.
You know, like, it like got the wrong wording, but like it means almost the same thing in your mind.
I would be okay if it had the word isosceles and base, and actually I think I would also want to say angle. So if you said base angle isosceles theorem, I'd probably be okay.
What do you like had isosceles something here?
If you said definition of isosceles triangle, I would take off.
I didn't put
Okay.
that.
You need to say isosceles and you need to say base at least, or isosceles angles or something. Okay. And I'm very forgiving in the wording of this, but it's got to kind of put it together. Okay. So now what can we say?
Triangle ABC is equivalent to triangle AEF because of SAS.
It'd be AFE.
Say again.
It'd be
Oh, I said ABC is congruent to AFE. And honestly, you probably would get away with that because it's hard for me to pay that close attention when grading. But
Makes a
yes,
difference on mine, so
yes. And it's what's right.
I thought, what did I put? Oh yeah, I think there's something about A, B is like, it's perpendicular to, triangle A, G, E, whatever that is.
It's interesting. Now we can actually say that this is perpendicular. Why are we allowed to say this is perpendicular?
because we didn't know it yet. Ready?
Because the perpendicular bisector theorem, or
Perp-
the converse.
Yeah, perpendicular bisector theorem says if these two sides are the same and these two are congruent, then this has to be 90 degrees.
I'm trying to say something like that. I didn't know it was called. I didn't know it yet.
Yeah, but we couldn't say that then, and it actually does us no good. I mean, we don't need it.
And then you could say AC is equivalent to AE because of CP.
AC and is congruent to AE because of corresponding parts congruent triangles are congruent.
Then because of that, ACD, angle ACD is congruent to angle AED
Why?
because of isosceles.
Why? Why do we need to say that?
Because
I
you
don't
need-
know, because we were scared during the test if we didn't say it, we were gonna get it wrong.
So we have now proved that this side is congruent to this side. That's all you needed.
Yeah.
Oh, wow.
So triangle ACE is isosceles. And how do we know that?
Definition of isosceles.
By definition of isosceles. The definition of isosceles doesn't say that the base angles have to be congruent. Okay, we just have to prove that the two sides are congruent. That one, most of us did pretty good on. We got more points out of that one than the next one,
Yeah,
which
I didn't-
honestly kind of surprised me. I think we got scared of this one because there was all this parallel stuff and
I didn't understand it.
I couldn't figure out that one, actually.
okay. One thing I want to say, I see this a lot. If this is parallel to say this, does that mean they're congruent?
No.
Absolutely not. Okay, so a lot of times people want to say that those things are congruent. They might be, but we have to prove it. Okay. And basically what we're going to do is we're going to prove that we have to prove that this triangle here is congruent to this triangle here. The way to do that is to prove that 1 is congruent to 2. And if you can prove 2 is congruent to 3,
Yeah, then you could say that one is congruent to 3.
then I can say 1 is congruent to 3 by the transitive property. Okay, so if I can prove 1 and 2, the other thing that I don't know that I did a very good job on this, but when you have parallel lines, basically you should be drawing a whole bunch of z's. Z's are the angles that are congruent. Okay, so I can draw a z that way, or I can draw a z that way. I guess I drew it backwards first. That's kind of funny. Okay, those are the congruent parts. it doesn't, we don't have anything that says anything about these parts out here because those can be cut off. It's just the z's. Okay. So first, I want to say, who wants to give me a first statement?
Right, you can say that angle EAF is congruent to angle AF.
And some people said angle A was congruent to angle F. Because there's more than one angle. You can't do that. EAF is congruent to, what'd you say? AFB. I think it would be the other way around, but I'm going to be okay with it. Given.
Okay, then we can say that AF is congruent to AF.
AF is congruent to itself.
Then we could say that angle EFA is congruent to angle FAB. Alternate.
Okay, so she's drawing a Z now. This Z right here. Okay, we'll say that that is congruent to that. The triangle or angle EFA is congruent to angle BAF because of alternate interior angles.
Then we can say that triangle AEF is congruent to triangle FAB.
Okay, so now we've proven that, or we could say that the triangle 1 is congruent to triangle 2. Why? Angle, side angle. Okay, somebody else take over other than Mark. So I've now proved that this triangle is congruent to that triangle. So now if I can prove 2 is congruent to 3, then I'm good.
Well,
Yeah, I mean it's basically the same.
Can't you say since 1 is congruent to 2, 2 is congruent to 3, 1 is congruent to 2?
No, you have to prove that 2 is congruent to 3 now.
So if I can say, yeah, I got to now say these. So I can't just say, oh, it's repeating, so therefore it's got to be repeating. We don't know that it's repeating yet. So
You have to prove it.
So this is the only thing I got. We know that the little angles that they already gave us are the same.
okay, but now let's start over and think about 2 to 3. How can I prove that 2 is congruent to 3?
Now do we need to make another C?
Yes. Okay.
Okay, then let's make another C.
And what would that Z be?
That C would be from A to B, B to F, and F to G.
So that's going to say that this is congruent to that.
Yeah.
So what's that angle?
That angle is BFG
BFG.
is congruent to ABF.
Okay. And that's alternate interior angles. Okay.
And we know that they both share the side of B to F.
BF.
B to F is from F to B to F. And that's reflexive.
Oh. Okay.
And now can we make a triangle?
We need one more piece. So we have angle, we have a side.
And we have a given angle.
Yes.
We have to write that?
Yes.
Okay, so now we need to prove that. Go off. Yeah.
Yeah, sorry. Running out of space.
Now we need to prove that the AF, well, we know that BFA is the same as FBG. Because it's given. And now you can see that those triangles are either
Okay.
because the
Triangle what?
triangle ABF is congruent to F and B. or other order, whichever you choose.
Okay.
And that is because of ASA.
That sounds like a bad word.
What sounds like that?
So
I'm
now,
gonna kick you in the ass.
so now, since we know that triangle 1 is congruent to 2 and 2 is congruent to 3, we can tell that 1 is congruent to 3 because of, isn't it symmetrical?
Symmetrical, no, symmetrical says A, if A equals B, then B equals A.
Well, I don't know the next step.
Okay.
Then you just copy that statement of the proof, and then you just say it's linked to different.
And it's not maybe super clear how that works out, but we've said it, right? Because it's up here. Like we could rewrite this and rewrite this statement and say, you know, if those are next to each other, then maybe it's a little easier to see that that's transitive. We don't have to restate it, but maybe logically it helps us. Okay.
Do you also use vertical angles for B, F, G, and A, F, E?
Vertical angles is when you have an X. Vertical angles is like that.
Oh, so you can have a straight line in there?
Supplementary angles.
Okay.
So here's my question, and I don't want to put Hope totally on blast, but I have a feeling that a lot of you are in the same boat. Like she finished that proof perfectly.
I did?
Yeah, didn't you? I mean, other than you didn't know transitive, but
Thank you, Rachel.
okay. So my question is, why did we struggle so much on this question on the test? Okay. Huh? If you struggled, why?
I didn't know this.
The Z's, okay.
The first time I
Oh,
tried
yeah,
all
I
the
was
things
confused. I
possible.
was just basically, I knew that isosceles one, like.
Okay. So we forgot so it's really knowing all those theorems, right? So that when we learn alternate interior angles are congruent, we're going to be saying that for the rest of the year. Okay.
I knew that. I didn't know the
And somebody asked me to assign the postulates quizzy. How many of you did that? Okay.
I think I did it once.
Yeah, that was I assigned it.
Yeah, I was one to ask.
Yeah. Yeah, I put it on Classroom. So that, you know, we have to kind of know those. So they expect you to just kind of have them, unfortunately. Okay. The worst part of that, how many of you feel like, wow, just watching that was a lot easier than I thought it was. And that makes you a little frustrated, right? Okay.
Oh my gosh.